All right, so we're doing function notation. F of x just means y. It represents the function. Independent variables, that's your domain. Dependent variables, that's your range. I'm giving you three functions, f, g, and h. And based off of those, we're going to do some function notation. Okay, so just some different ways that we could deal with it. Letter A says h of -2. So obviously, which function are we using here? We're using h of x. So that guy right there, that's the function we're using. We're doing h of -2. So h of -2 means everywhere you have an x, you are going to plug in -2. Simplify that, see what you get. We've got -2 plus 4 to the -2. So I got -2. What is 4 to the -2 power? Oh, it's not working. Please write. There we go. -2. 4 to the -2 power. 4 squared is 16. What's the negative going to do? 1 over 16. You guys are ready to go. I appreciate that. 1 over 16. The negative does the reciprocal. So a negative exponent gives you the reciprocal. Then we're just combining like terms. So I'm going to get common denominators here. So -32 over 16 plus 1 over 16 gets me -31 over 16. You could get decimal. We live with fractions if we can do it. So -31 over 16 on A. Letter B is easy. G of x plus f of -2. Oh, cool. G of x, I'm going to write down what G of x is. F of -2, so I'm going to go plus sign. And then f of -2, I'm going to write down this thing. But where I had an x, I'm going to plug in -2 instead. So right there, I'm going to plug in -2. Then I'm going to simplify. So 2x squared minus 3x. -3 times -2 would be 6 plus 5 is 11. Done. Can't do any other simplifying. Don't do magical things that you can't do. Letter C. This is one that's a little more common. G of -x. So it doesn't say x in there. It says -x. So we're going to write down what the G function is. That's this thing right here. 2 squared minus 3. The only difference here is instead of x, so inside those parentheses, I'm going to plug in a -x. What is going to happen when I take a -x value and I square it? It's positive. Okay, -x squared is the same thing as just x squared. So when we see that -x inside the parentheses squared, just make it x squared. And we got a times 2 in front. And then I've got a -3 times the -x. Oh, that's plus 3x. Done. Don't let that be harder than it is. It's just putting together what you got. Letter D says 3 h of 2. So it's 3 times whatever h of 2 is. Don't let that be any harder than what you got. Go ahead and try that one. And when you got an answer, show me with your fingers. What was 3 h of 2 going to get you here? 3 h of 2. Good. Seeing a lot of the same stuff. Look like we got a 54 here. Let's see if we agree. 3 times whatever h of 2 is. And so I'm plugging in 2 into that guy. So it's 2 plus 4 squared. 16 plus 2 would be 18 times 3. Got to break out your math skills, but that's 54. Letter E says -f of x. So do it. It's -f of x. Throw a negative sign down and then put some parentheses around what f of x is. So it's a negative sign times f of x. So my f of x is this guy. That thing right there. -3x plus 5. I got a negative sign in front, so all I need to do, distribute. Boom, boom. So it's 3x minus 5 there for my answer. 3x minus 5. And basically just change the signs of my f of x function. You don't have to show a ton of work. If you can do that in your brain, great. Write it down. Letter F is probably the most important one up here. Not that this one's hard. F of x minus 3. So we're using the f function. We're using this one right here. Instead of x this time, I am plugging in more than one thing. I'm not just plugging in an x. I'm plugging in x minus 3. So where the x was, inside the parentheses there, I am plugging in x minus 3. So to finish that thing, I'm going to distribute and then combine like terms. That's it. That's what you need to know with function notation. Be able to plug things in, be able to multiply by a negative, be able to plug in more than one thing inside the parentheses, and then just simplify. All right, if you can handle that, you should do pretty well with that. Down below, you've got A and B. You've got a new F and G function. Take a second here and try to do A and B. If you need to check with your neighbor, please do. All right, so we set this thing up on letter A. We've got F of negative 3x. So I started with this equation. Everywhere there was a negative 3x, or every time there was an x, what am I going to do from here? Samantha, what can I do? Wonderful. What happens when I take negative 3x and I square it? Wonderful. And then the second part? There we go. 9x squared plus 6x. She plugged in a negative 3x everywhere for x, and then simplified. Good job. Then I've got negative g times negative x. Negative g times negative x, or of negative x there. Kara, what'd you do with that thing? Yeah, so she's going ahead and distributing that negative sign. That's perfectly fine. I'm going to do it the other way just because I'm trying to be a good math teacher and doing it the right way. But yeah, I don't disagree with what you're doing there. So she threw a negative and times the front and multiplied through. And then what else do you have to do? Yep, so right there she's going to throw in a negative x. Good. What'd you get for your final answer here? Yeah, negative 4x minus 1. So there's a whole lot of things going on there. She's got two negatives there, but then she's got a third one. That's why the negative 4x. And then the plus 1 is going to become minus 1 when I distribute in there. Great. Letter C is the one that always kind of throws kids off. Not that our letter C is really difficult, but it's going to lead into our next one. So I've got f of x plus 1. So I'm going to write down the f of x function. But instead of x, I'm going to plug in x plus 1, x plus 1. So I got multiple places to plug it in. I plug it in both spots. I'm taking x plus 1 and I'm squaring it. What do I get what do I have to do if I take x plus 1 and I square it? I have to FOIL. All right, I have to FOIL. That is not just x squared plus 1. Every once in a while, a student will try to do that. That's not true. Okay, when it's squared, that means there are two of them. And so you have an x plus 1 and another x plus 1. If you've forgotten how to FOIL, remind yourself, or you haven't done it in a minute. I would suggest being good enough that you don't have to write this out. But if you do, that's fine. So this is going to become x squared plus 2x plus 1. Then I can distribute here. Negative 2x minus 2. Then I'm going to combine like terms. So I got a 2x here and a negative 2x. Those two things are going to cancel. And then I've got a 1 minus 2. So 1 minus 2 is going to get me negative 1 in the end. X squared minus 1 for C. Good there? Let's do part D. I want you to find on part D f of x plus h. H is a variable here. We do this quite a bit in calculus. Okay, H is a variable. Treat it like you would treat the letter X. Okay, see what you can do with that in terms of plugging in. So everywhere you have an X, you're going to replace it with X plus H in parentheses. Take a second. See if you can figure it out. Talk with your neighbor if you need to. I got X plus H plugged in, and then I got to simplify from there. Somebody want to describe what you did? Wonderful. What you got for us, Haley? Perfect. So she did x squared, then she multiplied this out, xh. She's got another xh and then an h squared. So she said that was x squared plus 2xh plus h squared. We're going to do that a ton. Probably not until March, but when we do it in March, it's good to memorize it because otherwise it's just super annoying to write that out all the time. Go ahead. Wonderful. Any like terms to combine here? Nah, that's it. Boom. There's my answer. Not any harder than what it is. They just throw a letter H in there to try to mess you up. Don't let it bother you. All right, backside. On the backside here, we are doing operations on functions. In theory, this is super easy. I decided to be the biggest jerk of all time and give you really annoying ones on the backside here, But other than that, it's easy. Okay, so don't let the weird fractions throw you off and think this is hard. F of x plus g of x. Okay, it just means take f of x, put a plus sign, write down g of x, and then combine like terms. Okay, they could also write it like this. That's what they did here on part B. So on part B, they took this f minus g of x and they wrote it a little bit differently. It just means f of x plus g of x. Don't let that bother you. All right, so once we see that, all right, cool, we're adding those together. So I'm going to write down f of x. I'm going to throw a plus sign. I'm going to write g of x. Oh, this is easy. I just put a plus sign. Combine like terms. I'm adding fractions. What do you need in order to add fractions? Common denominators, right? Good times. Remember back to good old 5th grade math. You need some common denominators here. This denominator is x plus 2. That denominator is x minus 1. They are not common, and so I need to make them common. So the easiest way to do that is to multiply the numerator and denominator over here by x minus 1, and the numerator and denominator over here by x plus 2. Okay, so I'm multiplying that together. I would not FOIL on bottom, just leave it. All right, x minus 1 times x plus 2. And apply x minus 1 times x plus 2. I'm multiplying on top. I've got an x minus 1 times 1, so it's just x minus 1. I'm multiplying over here. We could FOIL that out because we are going to combine like terms here in a second. So x squared plus 2x. Now I've changed these fractions to have common denominators. Now I can add them. That's the annoying part about this. It's not what I'm teaching you today. It's just that you're adding fractions. I'm reminding you of stuff. When I add fractions, what am I going to do with the denominator? Yeah, just keep it the same. Don't do anything weird with denominators. They just stay the same. X minus 1 and x plus 2. On top, we combine. I got an x squared, no other x squareds. I got an x and a 2x, so that gets me 3x. And then I've got a minus 1 tagged there on the end. That's my answer. Not exactly what you thought it was going to be when we started, but that's our answer. We added the two things together and got common denominators. It did ask us to find domain here. So if I were to find the domain here, all real numbers for my domain, but x cannot be what here? Can't be 1. 1 would be bad. And negative 2. 1 and negative 2 would be the two numbers I don't want here, because if I plugged in 1 and negative 2, I'd get 0 in my denominator, therefore undefined, therefore not a part of my domain. Annoying to get common denominators. Everything else make sense? On the second part, we're doing f minus g of x. So very similar to what we just did. Okay, take a second, see if you could do f minus g of x, and see if you can pick up what the difference is going to be. Let's do it. So notice how I'm going to cheat here, and here's how I started off here. I'm taking these two functions, f and g, and I'm subtracting them. The difference between this problem and the last one is not a whole lot. I literally copied and pasted. Okay, I'm going to subtract. Okay, cool. Still need to get common denominator, subtract. Everything's exactly the same. There's one thing that's going to screw students up here, especially when I taught it in Algebra 2. What's going to be the thing that's going to make a mistake here? Yeah, good answer. Distributing the negative. You've got to subtract both parts here because it's minus the whole numerator. And so that's going to become, I'm going to just change the signs. That would be the one issue that you have here. Just be careful with that. Once I combine them, I'm going to get, on bottom, I'm still going to get x minus 1 and x plus 2. My domain is the same as the last one. Nothing changed because I have the same denominator. Negative x squared. I've got a negative 2x and a positive x, so that's negative x, and then a minus 1 in the end. Just be careful when you distribute that negative sign. That's going to be the place where you make a mistake. Questions on B. We're done with the annoying ones. We got 2 left. They're not annoying. F with a dot in the middle. The dot just means multiply. Don't let that be confusing with function composition. We'll get to that later. F times g of x. We're going to write down what f is. We're going to write down what g is. and we're going to multiply them together. When we multiply fractions, how do you multiply fractions? How do you multiply fractions? Straight across, just multiplying straight across. 1 times x is x. This thing times that thing. I'm not going to FOIL it together because I'm just trying to find domain anyways. If I FOIL it together, it just make it more ugly. I'm just going to leave it like that. X plus 2, x minus 1. Done. I just multiplied. I multiply straight across. I'm done with that. Domain is going to be the same as the first two. Okay, it's still the exact same thing that we just got because it's still the same denominator. Don't let those be hard. Try the last one. F divided by g of x. Slightly different. See if you can remember your good old fraction rules. Divided by g of x. So Eli, how'd you set this up if we're dividing?
1 over x plus 2, and then multiply by x minus 1 over x.
Yep, so what'd you end up doing there? Yeah, we're dividing fractions. When we divide fractions, we multiply by the reciprocal. And so Eli there just flipped those two. And so in the end, now we're just multiplying, so it's easy. Multiply straight across, x minus 1. Multiply straight across, so x times x plus 2. That's my answer. I don't have to get any fancier than that. We do want to do domain here. So my domain is going to be all real numbers, but x cannot be, show me with your fingers, what two numbers can we not be this time? 0. If you want to show me a negative number, hold that thing upside down. And that's how I know it's negative. 0 and negative 2. Those are the two numbers here that I can't be. Because if I plugged in 0 or negative 2, I would get undefined. Okay, just a heads up here down in this review section. I give you a whole big old box. I'm going to do one problem here. Let's say on top I had like x plus 7. And on bottom I gave you x squared plus 9. X squared plus 9 on bottom. Find the domain of that function. X plus 7 on top, x squared plus 9 on bottom. What's the domain going to be? The domain is going to be all real numbers, but x cannot be what numbers? Show me with your fingers. All real numbers, but x can't be. I disagree with everyone. Disagree with everyone. Think about the numbers you just showed me. Plug them in, see what happens. So everyone just showed me like 3 and negative 3, right? What happens when I plug in 3 on bottom? Do I get 0? When I plug in negative 3 on bottom, do I get 0? No, so we're fine. That's part of my domain. We're taking the bottom and setting it not equal to 0. So x squared cannot be negative 9. I'm going to square root that. Oh, man, x cannot be plus or minus 3i. Right? It's a square root of a negative. It doesn't matter. Okay, imaginary numbers are not part of all real numbers anyways. That's why we say all real numbers. So it can be any real number we want it to be. It's imaginary numbers that throw me off there. Does that make sense? If it said x squared minus 9 on bottom, now the domain is all real numbers, but 3 and negative 3. But because of that plus sign there, the answer is just all real numbers. Just a heads up, that pops up a couple times on your assignment. I don't want you to forget it.